I request all of you to please settle down. We'll now have the first session of the workshop that is centered on standards in smart cities. The session will be chaired by Ms. Margot Daw and Mr. Babu Narayanan, Vice Chairman, TSDSI. Ladies and gentlemen, I would like to introduce Ms. Margot Daw. After holding various positions in the IT and banking industry, Margot Daw joined ETSI to launch a market intelligence unit. She has been working as Director for Partnerships and European Affairs. She graduated in Political Science and International Public Law and holds a postgraduate degree in Strategic Marketing. We welcome you, ma'am. We welcome Mr. Babu Narayanan, Vice Chairman, TSDSI. I would now like to request the other panel members to please take their seats on the dais. We have Dr. Omar Ilaumi. Ladies and gentlemen, please join us in welcoming Dr. Omar Ilaumi. Sir, I request you to please take your seat on the dais. Our next panelist is Mr. Seong Myung Jung, Sri Arindam Bhattacharya C. and Sri Bipin Pradeep Kumar. Now, I hand over the stage to the chairs for further proceedings in this session. It's over to you, sir and ma'am. Yeah.
A very good morning to everyone. Babu and myself have the immense privilege of replacing Mr. Kalsi, who could not join us this morning. So you have to bear with us. This is quite a unprepared session moderation, but the subjects are not really new to us because it's all about standards and it's all about 1M, 2M, and the benefit of this common service layer. So I think we are on safe grounds, even if, and by the way, you get 2 moderators for the price of 1, so you guys should be happy. So without further ado, I think we're going to move to the first speaker, which is Omar Ilaumi. I'm a little bit lost now because I'm going to introduce you. We agreed with the moderator, with the presenter that he would introduce you, but I'm going to introduce you myself. Omar is basically the chairman of the technical plenary of 1M, 2M. So he's really the highest authority you can think of to discuss the 1M, 2M common service layer. He is the head of M2M and Smart Grid Standard within Alcatel-Lucent Chief Technical Office. And he graduated in computer science and served in a number of forum industry association and industry and company. He's the co-editor of books on machine-to-machine communication and Internet of Things that have been published over time. And he is a well-known and very appreciated speaker in a number of international conferences on M2M and IoT. Omar, the floor is yours. And I love the way his name is it's mentioned by the speaker because it says Omar Ilaumi. So I think it's very nice.
Thank you very much, Margot. Do we know if the presentation is on this PC? Speaker presentations. And then this is the one. So then since with this introduction, allow me to introduce myself. I'm Omar Ilaumi. I'm based in Paris. I flew yesterday from Paris to Amsterdam, then to Rome, spent the night to Rome, then back to Paris, and flew to Delhi because of flight problems. The easiest part of my flight is when I arrived to India with this e-visa process. It took me 2 minutes to get through, and this is a nice, very, very nice example of what e-government is all about. e-government is an important part of smart city in my mind. The other important part, which is keeping me busy these days, is IoT and IoT-enabled smart cities. So, as Marco said, I'm the technical plenary chair of 1M2M, and I will provide quick introduction to 1M2M. The problem statement we try to address with 1M2M is convergence. And convergence means we have to bring efforts together and try to build this common service layer in collaborative efforts with different regions of the world contributing to this, and potentially verticals. And 1M2M is a partnership project, similar in its structure to 3GPP. TSDSI joined 1M2M, and I think there is a great potential for India to lead in IoT, and I strongly believe in this. There is an implementation by CDOT, and I see India is ramping up the efforts for IoT and for 1M2M, and we are extremely happy to see that. So when we speak about IoT, we start with describing use cases, and use cases have to be from different verticals and different industry segments, and this is how we structured the work in 1M2M. So we started with energy, enterprise, healthcare, to build requirements, and in 1M2M we produce documents. We call them technical reports and technical specifications. We don't have open source in 1M2M. We don't have provisions for open source. However, our members have driven open source in various standards organizations, in various open source organizations. We live in a world that's very, very complex, and very often people make comparisons about IoT standards. And the truth is that even though the picture is complex, there is some synergies that's taking place in IoT. For instance, there are the Open Connectivity Foundation is working on IP proximity networks, which is the home and the building domain. 1M2M, on the other hand, is working mostly on connecting different verticals. So we are the cloud area network for IoT. And we connect different technology, be it OCF, All-Seen, OMA, lightweight, M2M, and we built a number of collaboration to achieve our mission. This is providing probably a small picture of how we try to collaborate in order to achieve something that's relevant and that's consolidated and providing value to the market and to the industry. I spoke earlier about open source. We are aware of several open source implementations in Eclipse Foundation, for instance. There is one in Korea, and I think Samyong will be speaking about this. Linux Foundation, IoTDM, and a number of players have announced commercial availability or have participated in interop events, because interop events are extremely important. They show that we can put against each other two equipments from different vendors and it works. It's very, very important, because that's the foundation of avoiding vendor lock-in, which is what should be the basis of future-proof and sustainable development of IoT. So what we do is we build this common service layer, which is a layer that sits on top of the networks, be it in the cloud, the gateway, or the device, and the applications. And it provides API that are exposed to the application developers in order to expedite time to market for application development and deployments. And again, it's we are. Somebody said about this cyber physical system. So 1M2M is a highly distributed system, so we are not centralized. So intelligence can reside anywhere, and we bridge the gap between the physical world, the devices, and the digital world, because we make a representation of the physical world in our common service layer. So some of the functions that we are talking about in 1M2M include registration, discovery, security, group management, data management, so the ability of collecting the data and exposing the data to different applications. Device management. You cannot build an IoT system without device management, which is the ability for you to upgrade software, firmware. Devices that, it's not like those devices. Devices will be deployed for potentially 20 or 30 years, and you cannot imagine that you will deploy them with the same version of software or firmware. You have to upgrade securities, and you have to correct bugs. One M2M produced so far 2 releases of specification. One we call release 1, and we have release 2. Release 3 is now being progressed. This slide provides some of the features of release 2 on top of the features that I presented already. So the most important one, so we are moving to the industrial domain, and we are improving security. We are improving application developer experience. But one very, very important one is semantic interoperability, which is IoT is about exchanging data, but we have to describe what the data means, how to use the data, how to invoke services, and that's what semantic interoperability is about. It's about integration, and that's the most important value proposition of semantics. We deal with this with the notion of metadata. So a few words about smart city. There has been a task force, we call them specialist task force in HC, which did a study of different standards for IoT. And they came across very, very few ones for smart cities. So should we be worried about this? And the answer is, we do consider standards for smart cities the horizontal standards, which is provided by any horizontal standards. On the other hand, if you are speaking about standards for energy or street light, all of them, they exist. And the most important part now and the challenge moving forward is to bridge the gap between those different verticals. And that's why you see very little standards, because we think that the horizontal standards will apply for a smart city context. Actually, smart city is a wonderful use case for cross-domain communications between the different verticals, between the energy, transportation, and so on. So I spoke about different standards. For instance, for street light, there is a standard called TOLC, and I think Christophe will be talking about another standard for street light is DALI, and in one of them, we are not worried about those specific vertical standards, because we provide a vision where we can integrate them and build a data economy on top of that. So we have been looking at different smart city experiences, and this is providing a good summary of what smart cities and what the different prototypes and projects for smart cities look like. We have identified something that we call the anchor route, which is a vertical deployment, which is probably initial deployments of smart cities, which is very, very specific. We have the beta city route, which is based on building hands-on experience. It's learning by doing. And there is the platform route, which is now gaining traction because after initial experience, the cities came to the conclusion that smart city is not one vertical. Smart city is about collaborating different verticals using a platform. Now, if you agree to this concept, it becomes extremely important that you avoid any form of lock-in. This is, I think there was this presentation this morning. It's about how to make this sustainable development. The platform is not going to be deployed for 2 or 3 years. The platform is going to be a federating principle for the growth and sustainabilities within the cities. Vision for building smart cities. So if you are in doing this, we argue that you have to, first of all, every city is unique. Having said this, it doesn't prevent us from having platforms where we can build different applications and make that city unique. So in building smart city, we start by building a vision, installing our sensors and actuators, Then you have to master what's going on in the cities, which is building dashboards. For those of you who want to see what a dashboard is, there are demonstrations outside by CDOTS. They have few examples of dashboards, which is providing the visibility of what's going on. And then comes the most important one, which is opening the door for innovation, startups, SMEs to develop applications. And here we come to two conclusions. One of them is we need open APIs, ways to register, discover, act, open something. And the second part is using open city data. And open city data, it's not mandatory that all the data must be open. We have the means to make open city data and closed data coexist. It's perfectly feasible, and we have the means to make this in accordance to privacy laws and user consent. The integration challenge, this is what you see on the left-hand side. If you have few number of endpoints, you may succeed to integrate them by means of doing projects and integration. But if the number of endpoints becomes huge, which is what the city is going to be about, a huge number of devices, huge number of applications. IoT is about device and application proliferation. It becomes really, really challenging for you to make that integration work. And you have two choices, which is, one is the monoculture approach. You bring a framework provider, but that means a form of locking for forever. Or you have to go the open standard approach. And in this presentation this morning, one of the problems we see in this open approach is that cities, they don't have a large research department. They don't have standards experts. They are extremely focused, different departments are extremely focused on achieving a specific goal in terms of sustainability or energy consumption, which means one of the roles that, for instance, TSDSI or CDOT can provide is the set of guidelines in order to help the city pick and choose the solutions which are adhering to common standards, which allow for interoperability. I think there is a huge role and responsibility in order to achieve this. In the interest of time, so I present this slide. So again, smart cities is about device and application proliferation. And you will start with some killer applications, and then you will open the door for developers to innovate. Which is what we call the long tail. Now, there are two conditions for this to happen and to take place. The first condition is APIs. And if you want one application to work in city A and city B, it's better for you that those APIs are based on standardized APIs, because you can transport the application from one city to another. And the other one is laying the foundation for the data economy, which is opening city data, thinking about what data aspects or what data formats you want to expose to the application developers. This is a one M2M based smart city from Busan that's going to be presented later on. I will skip this slide. This is another one M2M in the UK. It's the One Transport project, another very, very important dimension of smart city, which is transport. Now, if I have to summarize some of the requirements and the challenges facing the cities moving forward is, and this is based on work done by myself with roughly 20 cities. They recognize that horizontal platforms is the way to go, the way to proceed, because they cannot sustain different verticals without any synergies between the verticals. And the only way to sustain this is by means of platforms. On the other hand, they tell us that we must ensure that we can make the best use out of existing deployments, which means please don't touch my existing deployments, but if you allow me to build adapters to your platforms so that I can absorb the data and make something useful out of it. Third point is build a framework where you allow participation and innovation, and I think I spoke about this. And last but not least, in original deployments of cities, the focus was, oh, how do I collect this data and make something useful out of this? How do I connect the sensors and different access networks, etc.? Now we are reaching a point where we recognize that security and device management are equally important. It's not only about collecting the data. You have to manage. I think there, in the speaker this morning, we spoke about, there was a mention of OEM system. It's extremely important because you don't want to build something non-manageable. And there has been several experiments where university guys showed that you can put at risk a complete smart grid infrastructure because it's not secure enough. So some areas for research and innovation is using machine learning to see what's coming up of the different devices. And if something goes wrong, we put the devices on quarantine until we build a software upgrade for it. So security and device management go hands in hand. This is a blueprint for smart city deployments, and we published a white paper that's available on www.1m2m.org. So, and here you will recognize the different aspects that I spoke about. If you look at the right-hand side, it's the vertical deployed applications where we can build adapters. 1M2M, the role of 1M2M is to provide a front end. So we don't, so we are building a very simple framework, which is device and application facing, and we expose things. But the standard allows significant room for differentiation, which is we build the interfaces, and it's up to you to figure out how the internals of the system is going to work. So we can work with different open source, for instance, fireware for the data exchange or exposure of the open city data. And the front end of it's based on 1M2M. It's dimensioned for device management, for massive IoT connection, massive number of connections. And what you have in the bottom is the different technology that we have to converge them together. And I list some examples for street light, for metering, etc. Now, so 2 slides for the takeaway here. It's first one is every city is unique. We have to accept and recognize this. Still, we can have an open platform can allow to recognize this notion of every city is unique, but because what will be different is the applications and the devices. If you are in a journey of building a smart city, you have to build a vision, the initial set of use cases, build an architecture that leverages cross-sector, integrate existing deployments, stimulate and cultivate a collaborative culture for innovation. And 1M2M provides a fast track to make all this happen. A second slide for the takeaway, and I promise this is my last slide, is again, cities need open standards because they want to avoid any form of locking to a platform or cloud providers. You don't need to lock yourself to a particular cloud providers. And it's also a matter of national sovereignty. It's extremely important. However, oftentimes cities, they don't have enough resources, they don't have the R&D power, and building blueprints, recommendations for them to facilitate their procurement effort will be extremely challenging, and I think this is where we, as a technical community, can help them. Multiple standards exist. In 1M2M, we think this device, gateway, and cloud communications, I think we are uniquely positioned to provide this unification framework. 1M2M should not be compared to OCF. 1M2M should not be compared to All-Seen because those are about proximity networks. So we are not competing with them. We provide the federation framework. Now, since I spoke about, we provide a standard for interfaces, and I would argue that's the less challenging part. We build the system based on RESTful APIs. The challenging part is to make your platform scale for a large number of devices, to build resiliency, no single point of failure. So actually, I'm in the process of writing yet another paper, which is about cloud-native IoT platforms applied to an M2M. And this is where there is significant room for differentiation and research. Applying, for instance, Apache Kafka for communication between the different software building blocks, microservices, no single point of failure, high throughput, low latencies. And this is where there is real room for differentiation. If you do this right, you will be able to manage large amount of data. There is a very huge debate about standards and platforms for IoT, and I argue that this is a largely non-needed debate because this is not where the value is. It's an enabler, but the value is beyond. Once you deploy that platform, is how to make the best of the data in building a data economy. I hope I'm keeping up with time. 2 minutes left. No, actually, I'm done. I'm very pleased to be here today. Yeah.
We request the next speaker, Mr. Seung-myung Jeong from Korea. He's a senior researcher at IoT Platform Research Center in the Korea Electronics Technology Institute. A long years of experience in this field, starting with in the industry from LG Electronics, then with OMA and 1-to-M standardization. And he's currently in Korea Electronics Technology Institute, working on the 1-MTM standardization. He's also the 1-MTM Architecture Working Group Vice Chairman. So please.
Thank you. Good afternoon, everyone. My name is Seung-myung Jeong from KT, and I was supposed to say good morning, but I must say good afternoon now. Since we are behind schedule a little bit, so I will be on time, make my presentation in 20 minutes. So the presentation slide, the title itself is Korean Smart Cities in Korea, and I will show you some deployment and some standard-related activities from KT side.
Duplicate. You have to duplicate the screen. Yeah. Now you can use it. Okay.
Yeah. Okay. Now it's on. So again, my name is Seung-myung Jeong from KT. So I'm so honored to be here to make a presentation representing some activities from Korea, because basically this is TSDSI and ETSI co-hosted event, and I'm from Korea, South Korea. So for the sake of time, I will go to the point, and my presentation consists with 3 parts. The first part is some government strategies for IoT and so on, and the second part is the deployments in Korea, the smart cities. And the last part is the KT activities related to smart cities here in Korea and over there in Europe also. So the first part is the R&D roadmap for the IoT technologies, and what I'm talking about is one of the Ministry of Korean government, which is basically Ministry of the ICT. The real name is MSIP in short. So they have several key topics for the ICT strategies in Korea, and one of them is Internet of Things, and we are kind of using it for the smart cities. And for the roadmap, there are like 3 different phases. And the first phase from 2012 to 2015, we were delivering the common platform, and that one is based on 1M2M standard. And from KT's side, we are providing the open source, which is Ncube for the device platform, and the Mobius for the server-side platform based on 1M2M. And the second phase is the platform interoperability, because there is more than one standard or non-standard, but de facto the platforms in the world for the IoT. So from KT side, we are doing some European side research projects like the Fiesta IoT and the WISE IoT. And as we are providing something for 1M2M, we are providing some semantic related interoperability technologies based on 1M2M, 2 different technologies. And the third part, the last phase, would be the intelligent platform from this year to 2020. So based on the achievement from the basic common platform and the platform interoperability with the other platform, we are adding something regarding the intelligence. So probably there is ongoing planning there from the government side that, okay, for the new project from the government, we are putting something addition to intelligence to the existing platform like 1M2M. So this is one of the snapshots that we are thinking of what will be that intelligent platform. So as you see in the bottom, so IoT capability layer, there should be many things, and one of them is 1M2M. And that's what we have in Korea, and we have from 1M2M standard, and we can add something for the intelligence, and we can see something intelligent platform deployed in the smart cities also. So that's the first part, and the second part is the main part, I think. So I'm going to introduce some smart cities pilot projects in Korea, and mainly I would introduce you 3 cities in Korea, South Korea. One is Busan, and the other one is Goyang, and the last one is Daegu. So firstly, the Busan Global Smart City. So there are 3 major operators in Korea, SK Telecom and Korea Telecom, in short, KT, and the LGU+. And the biggest one, which is SK Telecom, is the coordinator of this pilot project. And 2017, this year, would be the last year for the pilot project. So they have a lot of services deployed in the Busan, the pilot city. And of course, their platform, the name is Open Smart City Platform, and that one is based on 1M2M. And there are a lot of devices and applications deployed by SMEs. So as you see, the Busan is located like the southeast of South Korea. This is the second largest city in Korea. The population is like 5 million. Yeah. So I'm going to introduce you some smart city services. It has been started from 2015, and last year it was 16. There were the other services, and this year. So basically, there were some proposals from the SMEs, and they kind of proposed, okay, this kind of services could be beneficial for the citizens, and the city government and the whole consortium picked several projects. Okay, this could be deployed in the smart city in Busan. So if you see the category, some of them are like community safety, because safety is one of the best needs for the smart cities, like traffic management or something. And the other one is traffic improvement. I saw a lot of big traffic jam in India, New Delhi yesterday and today. And also in Korea, we have mega cities, and Busan is one of them. We have serious situation for the traffic jam. So we are going to improve smart city with some smart city related, traffic related services, like parking or crosswalk for the pedestrians' safety. And for the urban livings, we have the others, and energy is also important, so we have several applications for them. And this year, there are several enhancements or a couple of new services, like the smart tourism, and we already had the smart parking, but now this year they are bringing something for the electronic vehicle. So parking with the recharging for the electronic vehicle as an enhancement. And traffic management and traffic information system is also enhanced. And on the second point, I would like to make some highlight regarding the platform interworking and the security. Of course, there's another enhancement for the platform side to enhance the city monitoring services. But if I go to the platform interworking, so one of the government's IoT related strategy was platform interworking, because 1M is our main strategy, but there are a lot of things from the world. So, for example, we are building or starting some platform interworking from one M2M to the other one, like the fiber from the European side. Because in Europe, there are several cities deployed fiber for the platform of the smart city. So we are doing something, and I'm going to present this one in the later part. And 1M2M, as a standard, we provide a lot of features for the security, because whenever we talk about IoT or the smart city in different areas, the most frequent question would be, what about the security? And 1M2M standard provides enough or a lot of features for the security, so we can say 1M2M standard itself is really secure. And the thing is, before this year, we have not done everything for the 1M2M standard securities, but a couple of them. So now this year, they are going to bring more standard-based security mechanisms deployed in the Busan Smart City. So that's one of the remarks from Busan. And not even captured on my slides, but Busan has another deployment for the 1M2M compatible smart city, because this project, the pilot project, is led by the government, the Ministry of the ICT, but the other one is the Busan city government itself. So they are deploying 1M2M platform and the other services by the city government. So that could be another news for you. If I go to the next city, so if you see the map again, so it's near from Seoul, which is the capital of South Korea. So there is Goyang City. And the project name is IoT Convergence Smart City. So again, as one of the major mobile operator, LG U+ is coordinating this pilot project. And they're sharing the existing smart city platform deployed in Busan. So physically, the server would be in Busan, but they are also based on 1M2M. And again, there are a lot of smart city proposals and the devices deployed by SMEs in Goyang City. If I go to the services, so in general, some of the services are common to the Busan one, like the street light or the smart parking, because big cities need those services. And as a difference to the Busan Smart City, they kind of focus on some environment. So the smart ecosystem services or air quality management and so on. So if you see the screens, so they are aiming to bring the better city in terms of environment or ecosystem. And they also have the services for the open public data. And sorry for the screenshot, they are all written in Korean. But what do they for this open public data is based on 1M2M interfaces, they get all the data from the devices and the gateways deployed in the city, and they put it in the 1M2M compatible platform, and they convert it into the open API and provide all the data gathered to the 1M2M platform to the citizens. So they have this public data portal. So that is the second city. And if I go to the last one, here it is Daegu City. So as you see the map, it is between Seoul and Busan. And there is the consortium for the Daegu Daily Healthcare, the pilot project. and they're using 1M2M standard to gather all the data from the devices and gateways. And to the northbound, they are using like the healthcare de facto standards like ISO or IEEE, something, because the healthcare is a very specific area for the IoT or the smart cities. So they are focusing on the existing standards for the northbound, but southbound or the front end, they're still using 1M2M to use the standard APIs, standard interfaces to gather all the data to the platform. So if you see the services, so some of the services are like the fitness or the chronic disease management and so on. So they are focused on the healthcare, but they're using the 1M2M as the common open standard platform. And I have added one slide like, okay, the lessons learned from the Korean pilot project. So the first one is 1M2M standard is good in terms of smart cities because 1M2M by nature, it is the horizontal platform for different services like the parking or the energy management or healthcare or, and so on. So it is good to have as a horizontal platform because smart city, again, it is the system of systems and the collection of different service domains. So 1M2M is the best fit, I think. And with that horizontal platform, we can guarantee that interoperability over 1M2M interfaces. And nothing is perfect, even from 1M2M, so probably there could be the other extension to 1M2M standard or the deployment itself. So what we are thinking about is like the information models, because there are a lot of service verticals from smart cities. And from 1M2M standard, at least from release 2, we have provided one information model as a standard, which is the home domain device information models. But we have not covered all the verticals yet. So if we bring more standards for the information models for smart city related services, then it would be better to bring some cross-domain city services like smart city, smart parking associated with smart metering or the other smart shopping or, and so on. So we can bring some cross-cutting or cross-domain services based on the standard. And if we realize that one, then we can have more and more northbound MCA interfaces for the user-side applications. Because for the moment, we have some of the applications using 1M2M MCA reference point for the northbound or the backend itself, but not everything, because they lack of some guideline or probably we lack of some standard information model. So if we bring that one into standard, then we can have more coverage from the 1M2M standard into the real deployment of the smart cities. And for your information, in release 3 of 1M2M standard, we kind of opened a new work item for the smart city as a study. So if probably we can bring something to the standard as a study, okay, this is really good for 1M2M for the smart cities, and probably we need more in this area and this area. So from Korean 1M2M members or probably the CDOT or the other Indian members could contribute from our and their experience to the standard. And the last part is other activities that Katie is engaging in terms of standard or the smart cities. So there is, from the Busan Smart City project, we are the member of the consortium. And this year we are trying to build something like city-to-city cross services deployed. So the target city is the Santander in Spain, and from Korean side, we are connecting to the Busan, the smart city. And from Busan or Korean side, the platform is based on 1M2M, and from the Spain side, that one is based on the FireWare. And you saw that FireWare from the Omar's presentation. So FireWare could be the northbound, and 1M2M could be the southbound or the front end. That is one of the possible pictures for the smart city deployment. So the idea is if you use the 1M2M application for the smart parking in Korea, you can use that one because we have the platform for 1M2M for the smart parking. And if you go to Spain, they're going to deploy, and they are now working on deploying 1M2M platform in Spain. So you can use the same service with your existing application on your smartphone. And vice versa, if you are using the Fireware compatible application over there in Spain, and for your vacation, if you come to Busan, you can use exactly the same not exactly the same service, but basically the same smart parking service in Busan. And the need is like this. So we have different, as Omar says, every city is unique, they're different. For example, in Korea, mostly we use off-street parking, meaning parking lots are like the in-building facilities, and there's the gate when you get into the parking lot. And if you see the European case or the other case like Santander, the parking spaces or parking spots are on the roadside, so they are called on-street parking. So we have different deployments or different data model or different services, but we are going to provide the same service to the user based on this interworking from the technology side and the service aspect. So that's one thing, and the other thing is so-called Yes City framework. I heard that in Spanish this is called Yes. So this is IoT-enabled smart city framework. And basically, NIST is leading this work from the States, and they are bringing the framework documentation, and the due date or the milestone is the end of August this year. So basically, they are bringing some guideline or documentation. Okay, this is something that you need to consider when you try to build or bring your smart cities. And there are 3 working groups. The one is the application framework. So they collect all the existing applications from different cities. So they are going to deliver you the collection of all different smart city services. And the next working group is consensus PPI. And the PPI is, as you see, pivotal points of interoperability. So in an easy word, something really important for the consensus in terms of smart city architectures. And from Katie, as one of the 1M2M active member, we provide the analysis for their analysis, the Excel sheet from 1M2M technologies. So in the framework documentation later, we can see something from 1M2M. And the last working group is the deployed PPI. And that one is basically the best practices from the already existing deployed smart cities. And we have provided some inputs instead of Goyang City and Busan City to the framework. And before I go to the last slide, I need to verbally deliver the other news, because this is Etsy and TSDSI, the collaboration. So if I briefly go back to this slide to talk about Fireware and 1M2M. And there's the new standard group initiated from Etsy side, and it is called ISG-SIM. ISG is Industrial Standard Group, so it's a kind of incubation standard within Etsy, and the name is SIM, CIM, Context Information Management. So what they're doing is 1M2M gathers all the data because we are interconnecting with the other technologies like OCF, 1M2M, not 1M2M, lightweight M2M, and all join, and so on. And we have a lot of good features to communicate with the devices and so on. And the good thing or benefits from the Fireware side is the context information management. So I can query a kind of natural languages like, okay, I need the data of this and this and this area. So they have some benefits. And based on that framework, 1M2M and Fireware or Fireware extension, they are bringing the data publication platform with the API. So that is the new work from Etsy side, which is called SIM. And yep. And for the last, okay. this is one of the open source project, not the official from the 1M side, but from Korean side, we are providing this open source, which is called Ocean, the project itself. And this is one of the open source implementation from different members of 1M2M. And we use 3-class BSD license, and we provide Node.js and Spring Framework. So if you're interested, then you can download the open sources and use that. And not just the 1M2M, the core standard implementation, we also provide the OIC interworking, Ocean interworking, and the other interworkings for the proprietary the products like the Nest. And if you see this diagram on the bottom, so this is the resource tree view. And if you are a bit familiar with the 1M2M standard, everything is resources. And with this tool, you can see lively what has been added to the resource tree and what is being deleted in real time. So this is the tool that we also provide with the open sources. And the other one would be like the conformance testing tool, because 1M2M launched the official certification program this year, like February or March. So to ease your implementation and test by yourself, we provide a self-conformance testing tool. So you can try that one also. And we have the website for the Ocean, which is called iotocean.org. And we are going to provide the renewed version of the website, then you can have more access and more information from Korean side. Okay, I have 2 minutes, but I can recap very shortly. And I think 20 minutes is not enough to deliver all the messages from Korean side. So if you have any further question, then you can come to me during the lunch or afternoon or by email anytime. So thank you for your attention, and this is what we are doing from Korea and Kathy in terms of smart cities. Thank you.
Thank you very much. Now I have the great pleasure to invite Orindam Bhattacharya on the podium. Orindam is an engineer, and he's been working in CDOT for a number of years, in particular as a solution architect for several projects in intelligent network or data clearinghouse, and more recently the centralized monitoring system of lawful interception. In the area of machine-to-machine communication, he's coordinating the standards development activities based on the common service layer. He's also involved in some policy initiatives because he's been a key member of the group in the Department of Telecoms to formulate the policy document on machine-to-machine. And he is, was, but he is the chairman of the Gateway and Architecture Working Group of TEC, Telecom Engineering Center. He is an advocate of standardization and bringing the CDOT requirement into 1M2M, which is why we have the pleasure of seeing Orindam quite often in Sofia Antipolis in ETSI. Orindam, you have 20 minutes.
Yeah, thank you, Margot, for the introduction. And first of all, I'm delighted and honored to be able to present in front of such august gathering. Thank you very much for joining me in this endeavor to bring standardization into smart cities. All the other conferences that you have been attending, they talk about smart city and smart city initiatives, but perhaps this is the only one where we are talking about standards and not about applications, not about vendor locking, not about a product as such. So here I am. The topic is standards compliant common service layer and smart city architecture. See, it's a difficult proposition to speak after such illuminati of speakers like Omar and Seong Myung Young. It's difficult because he explains things, I'm talking about Omar, so beautifully and lays the foundation that it becomes an easy job for you. But at the same time, the expectations are so high for you that you get bogged down by your own expectations. Yeah. So once we say common service layers, before that, we should know what is smart city all about? What are we really talking about? So in this sense, me and my ADR, Shri Vipin Tyagi, we were having a discussion, and I couldn't resist the temptation of using the one-liner that he gave. So what he said is, the real smartness of a smart city is in using IoT M2M communication in standardized, safe, secure, accountable, and harmonized way to fulfill the dreams and aspirations of its citizen. Standardized, safe, secure, accountable, and harmonized. Just remember these 5 words. We will revisit them once again in the forthcoming slides. So now if you go to Smart City Mission's website, you will find there are 4 pillars of comprehensive development. One is physical, comprising of energy, water, transport, connectivity, and waste management. The other is social, which talks about education, healthcare, building homes, entertainment, and inclusive city development. Third one is economic, market growth, job creation, GDP contribution, livelihood activities, and the fourth one being the institutional, which is security, environment, ICT-based service delivery, enforcement, and skill development. Now, what is the objective? The objective is to promote cities that provide core infrastructure and give a decent quality of life to its citizens, a clean and sustainable environment, and application of smart solutions. So when we talk about the core infrastructures which are identified in the Smart City Mission are adequate water supply, assured electricity supply, sanitation, including solid waste management, efficient urban mobility and public transport, affordable housing, especially for the poor, and robust IT connectivity and digitization, good governance. And you have seen e-governance has been, has been there in our governance for quite many years now, and people are getting used to it. And the inclusion of Aadhaar into all other e-governance initiative is a very clear example of that. Sustainable environment, safety and security of citizens, particularly women, children, and the elderly, and last but not the least, health and education. Now, when you combine all of them, now these are certain smart city applications when you think in ICT terminologies. One is smart energy and water meters and billing systems, then remotely controlled automatic distribution valves, real-time online systems of monitoring water quality, citywide intelligent video surveillance network, intelligent transport system, command and control center, smart street lights, e-utilities for citizens, and e-governance. Now, if you see, all, or if not all, then majority of these applications are actually some kind of machine-to-machine or IoT application. When in a smart city perspective, they require sharing of data for the governance and management of resources. Now, what is the implication it brings? You assume that a realistic deployment is done for any such application or different applications for that matter. Now, the technologies can be different for all those applications. Now, there are 3 major implications on the communication framework, because we are talking about ICT to support the smart cities. And they are, first of all, the communication framework need to support the sharing of information amongst various service applications. Number 2 is the communication interworking amongst all the different protocols used by the sensor networks, because you will put up sensors to acquire information, acquire inputs for all those services which I mentioned earlier. And the third one is semantic interworking. So when we talk about sharing of information, there are diverse applications which will need the information to be shared among them. Communication interworking is necessary because when you deploy different applications would require different types of sensors. Different types of sensors may be talking on very different type of personal area network or home area network technologies, different network technologies. And these 2 network technologies, irrespective of network technologies, these 2 applications should be able to talk to each other. And the data need to be shared between the 2, then only one can create business intelligence which encompasses the entire city applications. And when I say semantic interworking actually works on ontologies. So that is the metadata pertaining to the data that is getting generated by the sensors. So when you are talking about metadata, the backend application should be able to identify what this data is all about. So that is where the semantic interoperability is necessary. Now, I'll give an example because data sharing example gets all the more clear once I give such an example. This is very close to my heart. So take an example of sensor pre-fitted cars. So the cars are coming nowadays pre-fitted with many sensors which send information to the manufacturer. This is predominantly the case because all the high-end cars come fitted with sensors, and the manufacturer themselves are putting these sensors in these cars. So the intent is to gather information regarding all these cars, how they are behaving, how they are being driven, and so many things, so many parameters, a large number of sensors. Now, you are not getting that car serviced by the manufacturer. You are getting the car serviced by a service provider who is next to you, who is close to you. That service provider also would be benefited and would require to access some of that sensor data. The insurance company, you are bound to take insurance for that car. The insurance company providing insurance for the car, he also needs information as to how the car is driven. And based on this info, he charges the premium. The fraudulent insurance claims can also be minimized, or it can be justified that, okay, a real accident happened, a real breakdown happened. The on-road assistance, many of us take on-road assistance in cities like Delhi. So the on-road assistance guy, he also would be benefited if he knows that where that particular car to which he is responsible for providing on-road assistance has failed or broken down, and what part of it has failed, so that he can rush his people over there to help you out. Now, the traffic police would also like to know any accident information, or maybe 2-3 cars have collided on a road which is very busy, so that he can first of all rush a towing engine, and secondly, reroute the traffic for traffic management. Now this information is useful for the commuters also to select alternate route. Currently, how you do? All the people who are accessing Google Maps are actually sending this information as to how their cars are moving to Google. And those who have access to that on their smartphones are able to make out, and Google is able to create that analytics that, okay, this particular route is congested. You see those red lines and those blue lines as to which route to follow. Now come to think of it, these sensors generating this data, now the manufacturer might need all the sensor data. The other people might not require all the sensor data, they only want a subset of data. But the data need to be shared. Now, what if it was vendor logged with the manufacturer, and the manufacturer did not allow this data to be shared? It's his prerogative. Would you put up as many sensors? So all these organizations, all these parties would put up their own sensors. Does it make sense? It doesn't. So data sharing in a smart city, this is one of example. There can be so many examples of implementation of such sensors and the sharing of data that you will feel that without sharing of data, this ecosystem of smart city is going to fail. Now in a vendor logged in scenario, this is not possible. So the current landscape is like this. It's vertical siloed. You have a parking system, parking application, automotive application. That application comes from a niche vertical. They provide all the sensors, they provide all the backend application, front-end application, and gone. Now the other application comes, which is a home application. All of them are sitting together. You say that all of them are sitting on a cloud, but it is not standards compliant. It doesn't give you a horizontal framework to share this data. How do you share this data? I have just listed only 4. There can be more, right? In order to share data amongst all these siloed applications, you have to create another layer on top of it. And then, at the behest of all these service providers or application providers, you have to engage with their applications, get information, and then provide to the management tab. Is it the optimal way of doing things? I don't think so. and nor did one M2M think that way. So that is the sole purpose, and that was the sole purpose with which the need was felt that a common services framework is created for such IoT M2M applications, which is the backbone of smart city applications. So now what we have over here, all such applications, automotive, home application, energy, health, so on and so forth, would have communication networks. Yes, all of them would have communication networks. Communication technologies and protocols, yes, they would. Communication devices and hardware, all of them, these are all common, maybe divergent, very divergent communication networks, all that. What is common among them is the common service layer. So you put up a common service layer, all of these talk through that common service layer, and the applications sit on top of them and gather information from this common service layer. Through access control policies and through the agreements and engagements with the data owner, this data can be shared amongst various stakeholders. And the management app can also be one of the applications like this sitting on top of it, taking input from this common service layer, not at the mercy of the application providers, which is sitting at the very top. Let me show it by some animated examples so it will make things clear to you. This is the scenario. Various service providers, telecom service providers, you deploy most of the IoT M2M applications, smart city applications, what they do, they put some sensors. GSM is the most preferred way of communicating, connecting because of mobility considerations. It is good, really. No denial of that. So they put SIMs. At the back end, there is some server, some application is running, and bingo, you're connected. So the data goes over there. So every application, every device starts sending data. No interoperability. You want two different type of sensors or two different type of sensors giving the same kind of output. Say for instance, traffic light. You don't implement traffic light through one vendor at one go in the entire city. Maybe different service providers, different sensor providers are providing those application sensors. Now if their sensors are not able to talk to common application, would it make sense? Would it make sense frugally? Would it make sense even technologically? Or from the common sense perspective, it doesn't. But that is the reality. Because of non-interoperability, all of them will be sending that data straight away to their respective business applications. Now come to think of it, when there is a requirement to share the data, separate set of sensors would be sending duplicate data, because now you are putting two business applications, you are saying two different applications want to share the data, two instances of data would be created and they will be sent to. So what will be there? A lot of duplication in the core network. The TSP's network will be overloaded by the amount of data. Why? Because we are talking about billions and billions of such sensors. So now perhaps it is making some sense to you that why we are talking about. Now imagine the data being shared by multiple business processes. It's looking chaotic in this small animation having only 4 such things. Imagine billions. So this is the vertical scenario that I have shown in the previous slides. And what we are talking about is this. Now this slide was shown by Omar also in us. So this was basically the thought process behind creating a common service layer. So when I say the common service layer being there in this ecosystem, how it behaves? It behaves like this. So all that data coming to common service layer, and you are getting the data, different business applications getting the data from the common service layer, not from the sensors. Right? So you are doing it optimally, you are doing it as needed, you are not replicating sensors, you are not multiplying the number of sensors, not multiplying the number of applications, your core network is not overloaded, and you are getting the data from this service layer. Now, when we talk about common service layer, now we said the access control policies in the common service layer, that would govern the sharing of data in secure and consistent manner. Security is paramount in this whole ecosystem. So when you are gathering data, information from the sensors to an application, the content is encrypted. The content is required to be encrypted. So when you are giving that data or the portion of that data to some other application, there has to be a proper agreement, a proper access control policy. And such a common service layer would actually provide that. Why? Why? Because in the common service functions that have been carved out to provide these functionalities actually give that. So this is part of this common service layer. So these are the 12 common service functions that were found to be common amongst all vertical applications. Now, what it gives the application developers a less burdensome task to churn out applications at a much faster rate. So the deployment of the services, development of the applications would be faster, deployment will be faster, and who's the gainer? The consumer is the gainer. And once you put it in a smart city kind of a project, the government is the gainer. Because the government would be providing or gathering information or run analytics based on these functions. So what are these functions? Basically, I'll touch upon some of them. Omar has also talked about some of them, like device management and application and service management. Registration. You would require all the sensors being put in a smart city environment to be registered. Why? Because you don't want rogue sensors to be there in this ecosystem who can send or bring down this particular ecosystem. We are not talking about mere passive sensors. We are talking about sensors and actuators. Because IoT M2M application doesn't only gather information and run analytics. It does the reverse function as well. You operate something. You operate something automatically. You operate something based on the inputs that you gather. So once you do that, you require each and every entity in this ecosystem to be authenticated, authorized. So registration is must. So to do this registration, not only the device registration or the sensor registration, but the application entity registration, which actually is having the intelligence of what this sensor is talking about. Discovery. Security. As you see, security over here is an integral part. It is given as a function. It's a service. So security as a service is realized through this common service layer. So we have group management. Group management, why? It's similar to CGMP. All my colleagues in C. would understand what I'm talking about. See, in a street light kind of a scenario, we have demonstrated that outside also in our stall, that you do not send one information or one command to each street light to turn it on. Neither do you send at one go tens of thousands of commands to tens of thousands or lakhs of streetlights to turn them on. So there has to be a mechanism of collating them, gathering them, and then send the notification to the streetlight to turn them on, or whatever, to dim it, to turn it off. This is one use case. There are a plethora of use cases like this. So group management is a function, so well perceived, well thought of. So all these 12 functions have been well thought of, and it has been found that whatever applications are there in reality today, they can be mapped to all these functions. So these functions are the common denominator for all such deployments, smart city deployments. Just a statement from Machina Research. Now it is a Gartner company. So open standards in IoT deployment would accelerate growth by 27% and reduce deployment costs by 30%. We are talking about trillions and trillions of dollars. How much of saving are we talking about? You can just imagine. So the design principle behind this is very simple. It's IP-based, but interworks with specific IP and non-IP technologies in M2M area networks. Your sensors might not be having the IP thing. Your health bands or other sensors which you carry, they do not have an IP stack. So be it, it's okay. They communicate through some gateway. Maybe they communicate through your mobile phone. Your mobile phone has got an application which is registered. And through that mobile phone, your device is registered. That mobile phone at the back end talks over IP. So that is only required. And how it talks? It talks over RESTful, resource-oriented APIs. So that is what is standards all about. When we say you are talking on standards-driven APIs. So those APIs are making you 1M2M compliant. So you talk only in terms of resources, where every device, every entity is a resource, and every data input is a content instance. Simple. Now after that, you assign attributes, you assign metadata to it. At the back end, the applications also are the registered entities to access that data, and you have a whole ecosystem of M2M IoT communications. The intelligence is distributed. That is, the intelligence is not confined to any core. When I show you the architecture diagram, you would understand what I mean to it. But just keep in mind this. Reuse of existing device management framework, Omar touched upon it. We have standard device management protocols already proven. So it wasn't necessary to reinvent the wheel. We didn't try to. 1M2M didn't try to. What it did, device management protocols, TR069, lightweight M2M, OMA, DM, these were the device management protocols already existing. So those were incorporated into it. 3GPP is an integral part of it. So whatever 3GPP publishes as specification, so interworking with 3GPP is already there. Same way, all the other applications, all the other application suites which are coming up, like Seong Myung talked about 5ware, and Omar also talked about 5ware. 5ware is an application portal, just like your application server, which has its own merits. That is also integrated. It's not competing with 1M2M. So that is integrated with 1M2M to give you additional functions beyond what the common service layer of 1M2M provides. And besides other things, reuse of existing security, that also we mentioned. Future-proof, ready to add semantic support. So your new innovations, that is important. So having a common service layer and not mandating anything underneath in the southbound and in the northbound sector, what you're doing is you're not prohibiting innovations to happen. Innovations will continue to happen in both the areas. So you simply let the innovations happen. You provide common APIs and have a common service layer, add common functions, and provide interoperability with the new things that are going to come. And this is going to stay for long. Now, no mandated implementation. It doesn't mandate any implementation as such. So again, I'm coming back to what Tyagi had stated. Standardized, safe, secure, accountable, and harmonized. Standardized means the communication framework with standards compliant APIs. People have platform, people talk about platform, IoT platform, so many. But the important thing is that, are they standards compliant? It has to be a standards compliant. Then only interoperability, then only harmonization will happen. So communication framework with standards compliant APIs. Then we talk about safe, that is safe to connect, driven by access control policies, trust, registered devices and applications. We say secure, standard security framework, then accountable, authentication, authorization, accounting, subscription-based access to information. So everything is accountable in this system. And last but not the least, harmonized. It is interoperable. Any device, any network, any application, it will be able to talk. Now, when we talk about smart cities, we create silos of smart cities. They become cocoon within their own system. You set up a smart city, deploy applications, deploy sensors, everything. You'd say that it is a smart city. Everything is happening automatically. But one smart city and another smart city can't talk to each other, because same implementations vary from city to city. Do we really mean that in the longer run? We don't. So from the technology perspective, this is like this. So these are the two major elements of common service layer. One is at the field side domain, that is ADN, ASN, and MN. These are the nodes as defined by 1M2M. And the common service at the core, which is an infrastructure node, and between them, it is IP. Now, everything around it is built. Now, you have sensors, on top of it, you have sensor network, on top of it, you have the core, which can be anything, any network. Then over it, a control platform where you do a capacity management, resource abstraction, operation control, business support, and then your application infrastructure platform, which can be a cloud-based entity where you deploy your applications. You can deploy any application over there. And what we talked about in the very beginning, all the 4 pillars of smart city mission are mapped onto it. You can achieve that on top of it. So these are the layers. So if you see in the physical terms, this is the architecture that we have been talking about. Below are sensors, on top of it, there are the PAN and MAN networks, where you have those field domain devices, and the M2M IoT service provider plays a role here, and he plays a role here. So when I'm talking about M2M IoT service provider, I'm bringing in a new entity into this whole business proposition. So I must touch upon how this is going to be rolled out. So this is my last slide. Thank you. So the M2M service provider registered with DOT. I take the liberty because there is an M2M service provider registration process, which is consultation paper. It's not yet finalized, but it's there. Now he sets up infrastructure node with common service functions, ties up with many TSPs, ISPs. Then the application service provider approaches the M2M service provider with their intended application and signs an agreement that I want to deploy such an application. The agreement binds them for application enrollment and registration, access control policies, use of security framework, exchange of keys, then device management, discovery, and other CSFs, common service function, besides commercial agreements. Sorry. The application service providers set up their INAE on their platform, that is a backend on the cloud, public or private cloud infrastructures, and the ASPs roll out application on the field. The management application also is one of the applications which sit on the cloud, and the governance can be done through that management application. So you can manage the entire resources, what are the resources. So you're not peeping inside the data. What you are seeing is actually how the resources are being utilized sitting outside, accessing the metadata or the analytics run on that particular resource structure. That's all I have to say. Thank you very much.
Thank you, Arindam. Now we have the last speaker of the session before we get on to some question answers. Welcome Mr. Vipin Pradeep Kumar. Mr. Vipin is a founder and director of Gaia Smart City. It's an IoT startup. But before that, he had extensive experience with Reliance Jio, where he also knew areas in the enterprise ecosystem and also responsible for all the products and platforms interfacing with the core telecom network. In fact, he is also the chair of the Smart City Group for the Telecom Engineering Center, Department of Telecommunications. He is also a core member of the National Working Group in ITU's study group, the Smart Sustainable Communities. So over to you, Mr. Vipin, and if you can keep it 20 minutes, great.
Thank you, Babu. I'm the last speaker, and thankfully they've all spoken a lot. The good news is you'll all go for lunch faster. The other thing that I want to say is before I start this, my topic is supposed to be about standardization in Indian smart cities, but I'm going to take a small detour and go to China. If the presentation starts, yes, it does. So that was my agenda. I'm going to talk about 3 things: standardization in China, the Indian smart cities, and something about how we need motivation and direction. So to start off with, I'm going to start off with a completely different topic, and that is cement. So the picture here shows on your left is the consumption of cement by the United States in the last 100 years. If you can read, it's 4.5 gigatons. On the right is China's consumption of cement in 3 years, which is 6.6 gigatons? Yes, 6.6 gigatons, which is 1.5 times what US used in 100 years, China used in 3 years. Now, why am I talking about cement? Well, obviously, what cement means is construction, and construction means urbanization, an extreme pace of urbanization, and you can't do it without automation. You can't do it without automation in all the areas that we're talking about: energy, water, transportation, logistics, security, manufacturing. You can't do without all of this. And this is what China has done. And this was not lost on China pretty early on. 2009, when the premier himself identified sensor networks, the need for sensor networks, and institutionalized that. Going quickly, in the interest of time, in 2012, they included IoT in their 12th five-year plan, and said, as you can see there, a plan for IoT, and also said nine demonstration areas, as they called. And that was in Feb 2012. By August 2012, the NDRC, which is the equivalent of the National Development and Reforms Commission, they had identified 9 areas: transportation, public safety, agriculture, and all of these. And they had given it a funding of $600 million, right? That was how fast they did it. And for people who can't see this, this is the central government laying down how they're going to approach IoT, right from the business model at the bottom, ideally it should have been on top, how standards are going to come in, the integration of civilian standards and military standards, and of course their approach to international standardization. They also spoke about security. They also spoke about these application areas and how it is that these application areas are going to work in standardization. Shortly after, they announced these projects in how this will be financed. And like we have these schemes and various approaches to it, they had 1, 2, 3, 4, 5. They call it mega projects. In these mega projects, they outlined $603 billion to the year 2020 in all these areas. I'm talking about this not to compare, but to inspire. So that was on IoT. Similarly, in smart cities, but learning from here is, while they announced smart cities in 2011, it wasn't until 2013 when they actually created something called the Strategic Alliance for Smart City Industrial Technology that they actually moved faster. So in 2 years, out of the 320 smart cities that China planned, they had actually already started off work with 230. And the budget that was announced there, $320 billion. So roughly, if you look at the money that goes in between the smart cities and IoT in China, it's $1 trillion. Simple math. And most of them began work in less than 2 years, yes. Now, these 9 demonstration areas, I'm also very hungry, so we'll go really fast. Industrial area, agricultural, financial services, smart grid, and all of them really huge. If you look at smart grid, they built 18 intelligent substations just to show it's a demonstration, right? Yeah. Similarly, intelligent transportation, logistics, medical and healthcare, and smart environment. In environment, here in India, we're talking about particulate matter 1, 2, 3, and another few different chemical substances. There, they are measuring 15,000 key pollution sources. I don't even know how they're going to get 15,000 pollution sources, but yes, this is the information that has come through. So you're all telcos. Telcos have been playing a crucial role in what China is doing, and pretty much every solution has one of the major telcos in China participating. And I don't know how they've broken it up among these provinces and cities, but this is what they've done. And all the major telcos have taken different cities, different provinces, and looked at different solutions. In fact, they have even set up a dedicated network for IoT. Well, on that, I'm pretty impressed to see that we're not far behind. Kakinada is among the first city to have said that as a smart city, we will take up a low-power, wide-area network just for smart city services. So yes, that's good, so we're not far behind. In standardization, they have the CCSA equivalent of our TSDSI, and they have, in the technical committee 10 is where they have said they look at IoT and smart cities. And similarly, they have these 4 working groups, how they have outlined it. Their approach in this has been no less than phenomenal. These are these different standards that CCSA has launched. Then they have something called the industrial standard, and then they have something called the national standard. And they have broken it up very clearly, who does what and how it is done. It's remarkable when you look at what all they have launched, right from a smart home network standard to agriculture standards, to environmental protection, to video analytics and surveillance, to vehicle networking, and they have launched all this in the last few years. And again, some of them are industrial standards, some of them are communications CCSA standards, and the others are national standards. In fact, I'm sure most of you already know this, how they have been pushing at the international level too. A lot of the ITU standards now are sources from China, have originated in China. This slide, in fact, shows you the number of documents or standards that China has released. And some of them are split into regulatory standards. The other is industry standards. And again, some are communication standards. Phenomenal numbers if you look at it. 493 as 495 as national standards, 2,775 as communication industry standards, another 83 as technical documents, and another 123 as communication standard technical reports. I don't know what all this exactly means, but I guess you can all figure out. So having said that about China, like I said, I'm using that to inspire, not to compare. I'm going to talk about the smart city deployments in India. So several people have already spoken about this. This is when we analyzed the 60s. I mean, India has announced 60 smart city proposals. I've appointed 60 so far. When we analyzed the different proposals from all these 60s, well, this is from about 50 plus, we realized that, we get the figure that it's not just entirely IT, right? I mean, there are 54% of the solutions that are being deployed by cities are non-ICT. And it's only 46% of the solutions that cities actually deploying are ICT-based. I think this number may come to about 48 and 52 by the time we finish the remaining, the remaining 10 odd that we have yet to do. In the among the ICT solutions, this is the distribution of the solutions. Transport occupies the largest space. 25% of the solutions that cities want are in transport. Energy is next. The yellow one that you see there that you don't really read is connectivity and command centers, which is another 11%. Waste and the others, apps and all that, form the other 31%. So this is a distribution if you look at how the solutions that cities want today. If I can break it up into area-based, that's how smart cities in India are classified as area-based development solutions and pan-city solutions. That means one solution that has been deployed across city, or few solutions that have been deployed across the entire city. This is the number. Again, let me move fast. What I'm getting to here is coming here. In fact, I've used this slide several times before, but I've never been able to get something as simple as this to demonstrate interconnectedness. This is a number. And anybody guess what this is? It's 6.5 billion. I've shown this actually a couple of times. Even if somebody's seen this, you're welcome to, say what it is. Anybody? Sorry? Sorry?
It's dollars.
Yeah, it's $6.5 billion. Yeah, not rupees.
It's dollars.
Yes, correct. Yeah, $6.5 billion. But what is the number? What does it represent? That's the question. What is this number? I know it's dollars. Thank you, Margot. This was a number released. I mean, I didn't do this. It is the monetary cost of traffic to Bangalore's two industries, IT and BPO, in 2013. $6.5 billion. Just to two industries in one city. Now, this is another number. I'm sure you all know this. 1.8 trillion. Sorry, yes. That's India's GDP for the same period, 2013. Yeah. This number is 0.36% of that, right? Another number, $85 billion, no more questions. It's India's oil import bill for the same period. Number, 7%, if you take it. At the same time, what is India's current account deficit? $37.4 billion, 17.3%. All these numbers, your current account deficit, your GDP, all these numbers affect your rupee convertibility. All these numbers actually mean that if these numbers were different, you would actually end up paying less for your phones that you import, your televisions and computers that you import. I mean, I think, import over $400 billion worth of electronics. Forget about that. Your petrol would be cheaper. But what I'm going with it is, something that happens in one city is not restricted to that one city alone. It affects the entire nation. It affects the entire nation in more ways than we even realize. So yes, that is what I'm trying to show with this. So quickly moving on. So we analyzed the Chandigarh proposal. This is part of the task force, as part of the IoT for Smart Cities task force, which METI had sponsored. Pamela was not here, but yeah, she was one of the people instrumental in this. Taking all these areas that we spoke about, public safety, the government services, transportation, smart water, energy, healthcare, major solutions. In fact, all of these are listed, I mean, when I say PC activity there, as part of their proposal, it says Pan-City Activity 1 and 2. Similarly, ABD. But what we realize, or what you will realize, is that, when you do something in the transportation area, it impacts another area. For example, like you see there, I mean, reduced traffic congestion reduces emergency response time. Having public safety actually increases adoption of public transport. I mean, I'm sure I let my kid go out if I know he's safe. Use public transport rather than use cars that he uses. Similarly, I mean, if you can buy your, what is that, the metro tickets online and not stand in the line, you'd probably have a lot more people using it. And this is what cities want. This is what governments want. But I mean, in the interest of time, again, let me move fast. But you will see this. I mean, this goes around. I mean, one area affects another. One area affects another in more ways that we know again. If you have less energy consumption, it results in your lower energy bill. You have better public transport, it results in better, so it goes on. Same Chandigarh proposal we analyzed, and Arundam spoke about having these different services, and you can't get better than this in terms of explaining these complex services. So you have Chandigarh wanting transport, energy, building, and environment. But of course, needless to say, all the tenders, it's not just Chandigarh, but pretty much every city that issues a tender, for lack of whatever it is, they issue a tender from transport department. And transport department, well, I think the officials know about it. I mean, they can't do anything. It has got no connection with the energy department or the environment department, pretty much nothing. But if at all you wanted to have a system where, where the transport department knows where there is, there is, from your hospital, there's an ambulance going, and that data belongs to some other department. But you need to change the signal, it belongs to the transport department. So you have to be able to share data or share services using this common service layer. Yeah, so you need to do this. Similarly, I mean, if you detect heavy pollution, data generated from one department, you need to change your traffic route. It's another department. Yeah? But you can do it. You can detect pollution, heavy pollution, and route traffic accordingly. You can also do more, because cities now want a smart card where it's one payment card. You can actually incentivize the citizen for using a better route. It's possible today. If only systems spoke, if only systems exchange information using several of these systems that people talk about. Let me move fast through this. This is, you can't do without IoT, ICT, no matter what cities talk about. And this is how you move on, from siloed independent cities. You must have heard the word siloed several times today here, right? To interdependency among city functions and interdependence among cities also. And this needs, at minimum, I don't need to speak about this. Several people have already spoken. Your common service and APIs and your data models and ontologies. And this is part, the data models and ontologies, I don't see Mr. Sushil Kumar here, but it's part of the TEC thing which they're working on in terms of getting different data models standardized, or at least pre-standardized. So collaboration, I'll move really quickly. How many minutes do I have, Margot? Oh, I'll take 2. So these are all the different institutions working on, I wouldn't say standardization, I would say pre-standardization between all of this, TSSI, TEC, DOT, BIS, some of them on standards, some of them on getting frameworks or guidelines in place. And then there's the METI supported task force, and then there's TRI. Now, this is some of the work that they're doing. There is the DOT that is working on a reference framework, specification of data model, general characteristics, and then the the task force which is working on use case analysis, reference architecture, and Mr. Salem, you spoke about RFP guidelines.